Okay, this is the second question of the final for Physics 102 in spring 2018. We're asked to consider a circuit that has two resistors and an inductor and a DC voltage source. And there's a switch which is closed at time t equals to 0. Before the switch is closed, all the currents are 0. So at the moment the switch is closed, the inductor resists this change of current. So momentarily, its current will not jump. So it will act like an open circuit. It's as if I cut out the inductor from that circuit. So this is the situation at t equals to 0. So we are asked to find the current I. This is V. Clearly, I have two resistors in series. So the initial current will be V over 2R. Right. How about the final current? After a very, very long time, the switch is closed. Then inductor now becomes as if it's just a short circuit, right? It resists the change of current. So there will be a value of current which is constant, and there will be no potential response to it. So now it's as if I have a short circuit here. This is t going to infinity. When I have this short circuit, there is no current on the second resistor. So all the current runs from the first resistor. This is V. So I final will be V over R. Now, the hard part is finding the current as a function of time. And one way to do it would be to use Kirchhoff's equations and remember that the potential across an inductor is L dIL dt. But I'll actually do something a little bit more tricky. What I'll do is, I know that this is a circuit with a single inductor, so it will give me a first order differential equation, which has only solutions like e to minus t over tau. So what kind of current do I expect? I expect the following. At t equals to 0, I t equals to 0 should be V over 2R. At t goes to infinity, I of t equals infinity is V over R. So if I do the following, I of t is V over R. Right. At t equals to 0, it's V over 2R. At t equals to infinity, it's V over R. So let's do it V over R, 1 minus 1/2 e2 minus t over tau. When I put t equals to 0, that gives me V over 2R. When I put t equals to infinity, it gives me V over R. So this is nice, but what's the time constant? Look at the circuit. When I'm looking at the time constant, I can forget about the voltage source. I have two resistors in parallel and an inductor. So the time constant, which would actually ideally be L over R equivalent. R equivalent would be here, R over 2, so it's going to be 2L over R. So the current on the inductor as a function of time will be V over R, 1 minus 1/2 e2 minus t divided by 2L over R. If you're confused by this solution, the official solutions of this problem actually run nicely right out the differential equation. You can follow that.